So to write the electron configuration of an element, we have to first identify its atomic number, 16 in this case. We are working with electrically neutral atoms. So it means the same number of protons or the same number of electrons. So 16 electrons is what we are going to represent here. We have to apply the rules of the electron configuration. We start with the lowest energy orbital. One electron has a plus 1/2 spin that we represent with an arrow going up. And the other electron has the negative 1/2 spin. We represent with an arrow going down. So we have to arrange 16 electrons in the different orbitals. The next orbital is the 2s. 1, 2, we have 4 electrons already. Then they generate 2p orbitals, 2px, 2py, and 2pz. Degenerate means that they have the same energy, okay? These all have, they are all degenerate. So we have to put electrons first in the free orbitals before pairing them up. So 4, 5, 6, 7, 8, 9, 10. Then we continue with the next orbital, which is the 3s, 11, 12. And then we have another set of degenerate orbitals, in this case, the 3px, 3py, and 3pc. These are all also degenerate. They have the same energy. So that's why electrons occupy the free orbitals before pairing. So we have 10, 12, 13, 14, 15, and 16, okay? So this is the complete electron configuration. So we can write this in a more condensed form or short form. And we just have to indicate the orbital and the number of electrons. For example, 1s has 2 electrons. The 2s has 2 electrons. The 2p's as a whole have 6 electrons here. So we write 2p6, then 3s2, and the 3p's as a whole, they have 2, 3, 4 electrons, okay? So now we identify the highest energy level. As you can see, this big number here represents the energy level. So the highest number is number 3. So these 2 sets of orbitals are the valence electrons or the external electrons, okay? And the rest of the orbitals, which are not the highest number, are the inner electrons, okay? So we count them. 2 plus 2 plus 6 gives you 10 inner electrons. And we count 2 plus 4. We have 6 valence electrons. Now we're going to represent these electrons. These valence electrons are going to be represented in a Lewis structure. The Lewis structure is simply the symbol of the element, in this case S for sulfur. And then we write as dots the valence electrons. So for example, 1, 2, 3, 4, 5, 6, okay? They can be in other arrangements. For example, 1, 2, 3, 4, 5, 6. It is correct because it means that electrons can rearrange around the nucleus, okay? So this is the Lewis structure. And the final part is to represent this condensed electron configuration in a shorter form. So these inner electrons have exactly the same configuration as a noble gas. In this case, the noble gas is the noble gas that has 10 electrons. So you go to the periodic table and you notice that the only noble gas that has 10 electrons is neon, okay? So in order to substitute all of this part, we just write between these brackets, the neon core, and then we write the valence electrons. So 3s2, 3p4. Okay? So that is how you finish this exercise. All right.